In this section, we're going to talk more about the JSON that is sent back and forth in the request and response payloads. You're writing your service in one programming language, and you want consumers or clients of your service to be able to use whatever programming language they want in order to talk to your service. So that means that on your service, you can't use data types that are specific to your language that don't exist in another language. We have to have kind of a lowest common denominator type system that is used to send payloads back and forth across the wire. So today, most services typically use JSON for this. JSON defines only 3 data types in it, but everything is sent over the wire using UTF-8 bytes. The 3 data types that JSON supports is Boolean, which has a value of either true or false, a lowercase. JSON also defines a number, which is really a signed floating point value that fits very nicely into a variable of IEEE 754 binary 64 variable. If you want to send an integer over the wire, then you have to send it as a number in JSON. And using IEEE 754, that integer range is from -2 to the 53rd power minus 1 to +2 to the 53rd power minus 1. So a lot of services, they would like to use 64-bit integers, but that's not representable in some languages like JavaScript, which treat all numbers as these 64-bit floating point numbers, which limits the integer range that's possible. So try to stick to integers that are within this range that I show here. And then the third and final data type that JSON supports is string, and that's really used for everything else. If you're using a string, then you have to be very explicit, it's a contract, as to what the format of the string is. So you'll want to think about things like, what is the maximum length of the string? Is the string case sensitive or not? What are the legal characters that can be used in the string? And you want to make sure that the string is round trippable. You might pass a date time in a string, and then some languages might parse that into a date time. And then they might take the date time and format it back to a string to send it over the wire. So you want to make sure that this is round trippable without any loss of precision or resolution. Strings are used for a myriad of things, such as dates, times, durations, where we recommend to use RFC 3339 as the format for those strings. That's the contract. UUIDs, RFC 4122. Enums, which I'll talk more about very shortly. JSON also supports objects, which are really just collections of key value pairs where the keys are strings and the values can be a Boolean, a number, a string, or possibly a nested object as well. And finally, JSON supports arrays, which are an ordered collection of objects, JSON objects or values. However, we recommend that you avoid using JSON arrays. And the reason is because they do not work well with JSON merge patch as a mechanism for updating a resource. If you're trying to use JSON merge patch to update an array, the client has to read the array first in its entirety, then sort the array or remove elements or add elements. Then it has to send the array back to the service in its entirety. And that's a lot of work for a client to do. So instead of using arrays, we recommend that you use a map instead on the service in the resource. And then it's very easy for a client to say, I just want to add this to the map, or I just want to remove this from the map. And of course, they could get the entire map if they want to and change it, but a lot of times they don't need to. They just want to add something in or remove something. You can lose ordering with a map, but a lot of times the order of the elements doesn't actually matter. Arrays will maintain the order, but they don't work well with JSON merge patch. Let's talk a little bit more now about string values, enums, and SDKs. Well, let's say that you have a resource and one of the things you can set in is a person's state that they live in, like Washington State, which is where I am. Well, you can easily document for customers that there's a state property, it's of type string, and these are the valid states you can put there, Washington, Pennsylvania, what have you. And then you make that part of your documentation. But the OpenAPI specification also has a formal concept of an enum, where you can specify in the OpenAPI JSON document, here's what all the possible values are, and then you could list in there Washington, Pennsylvania, and so on for all the various states. And the benefit of doing this and putting it in the Open API specification for your service is that this can improve the developer experience because it's now part of the documentation. Some people generate their service docs from the Open API specification. And then if you take that Open API specification and you run it through tooling that produces SDKs or client libraries, those SDKs, or those tools rather, can see the enum values and can go and spit enum data types into the client libraries. And the benefit of doing this is that you get some type safety at code editing time. Right? In your code editor, you can get code completion, where it says the possible states are Washington, Pennsylvania, and whatever, and then you can just pick from the list rather than having to say, quote, Washington, end quote, or quote, Pennsylvania, end quote. So the code completion gives an improved developer experience there. But for SDKs, the different languages handle enums differently. In C and C++, for example, there's no metadata or reflection APIs that are built into those languages. So there's no automatic way to convert a Washington enum symbol into a Washington string to go across the wire, or vice versa. Washington comes in across the wire, you want to convert it to a Washington enum value. There's just no way to do that built into the language. Somebody could write that code, or a tool could write that code, but it's just not there naturally. And other languages like Go doesn't even have the concept of enums at all in that programming language. So we end up having enums, they appear very differently depending on what programming language the customer is using. And that can cause some pretty significant problems, which I'll mention in just a moment. Another thing to be aware of is that you should never send enum integers over the wire. Let's say you have a service written in C#, and the enums in C# are really all integers underneath the covers. What some services do is they take the enum value, let's say it's a 7, and then they convert it to the number 7, and they send the 7 over the wire. Well, there's no way any other language is going to convert that 7 back to what it was. So you need to send the string over the wire, not the numeric value for the enum over the wire, because it will make no sense in other programming languages at all. So the next problem with enums is that they can cause versioning issues. Let's say that in version 2 of a service, the new state gets added. So we add a new state, let's call it foobar, to our list of states. Well, if a client goes and gets a customer resource from the service, a V1 client gets a customer resource from the service, and foobar comes back in the state, so foobar comes across the wire as a string, the client library then wants to convert foobar to a symbol, but it's a V1 client that's getting this. The V1 client didn't know about this new state foobar, and so the V1 client can't convert it to the enum. It ends up throwing an exception. The exception ends up being unhandled, and the client program crashes. That is unacceptable. So you cannot add new symbols to an enum value over time. In different versions of your service, that's a breaking change. Also, let's say you want to remove a symbol. Let's say Washington State is no longer part of the United States. So you want to remove that from your enumerated type. Well, a V1 client, it thinks that Washington is still valid. And so a V1 client can still send Washington up to the service, and it used to succeed in doing that. It should still succeed today in doing that. Otherwise, you've broken the client again. So the end result of this is you can't remove symbols from enumerated type either, because it causes breaking change over versions. So when you use enums in your Open API, you've really restricted yourself to something that can't easily version over time and can cause breaking changes. So you need to be very cautious about doing that. Now, I do have one caveat here at the bottom of the slide, which says that you can add and remove enums if the enum is used in an ephemeral way and is not persisted as part of the resource. For example, let's say that the client makes a request to a service and there's some query parameters with some enum values that are there. And then the service does some work and then just returns a response back to the client. It's not persisting anything. It's just performing some operation and sends the result back to the client. That's what I refer to as being an ephemeral operation where nothing is being persisted. In that case, a V1 client can use some symbol in V1 and send it to the service, and it can work. And a V2 client could add a new symbol, and the v2 client could use the new symbol, and it would also work. The problem with the persistence is that if a v2 client persists a value that a v1 client didn't know about, then the v1 client will usually throw an unhandled exception when it gets it back. But if it's just all ephemeral, that means you know it's from v1 to v1 or v2 to v2, and then there's no cross-version communication that's happening there, and that ensures that it works properly. A little bit more about string values, enums, and SDKs. Microsoft's tool to process OpenAPI is called AutoRest. And this tool has some enhancements to it that are not part of the standard OpenAPI specification. And one of the things that it has is this thing called Extensible Innumes. In SDKs, what this means is the enums that are described in the OpenAPI specification, they are going to be modeled in programming languages as strings and will not be modeled as enum integers. And because they're really just strings, that means they're really just strings. And so they now become easier to version. So the contract with the customer when exposing an extensible enum is an extensible enum is the partial set of suggested values. So it might have Washington State, Pennsylvania in there, but these are just a partial set of suggested values. So you get some improved developer experience and you get some improved documentation, but if the United States adds a new state in the future, the customer could always just manually put that state in themselves in their own string. They don't have to use a string that gets generated by some tool, some property generated by a tool that represents a string. So they would lose IntelliSense for the new thing, but they can still do it. So other values are still possible. The client code should expect that undocumented string values might come back. So a v1 client might not expect a foobar state to come back. But because we've documented the state property as being an extensible enum, that says to the client, these are possible values, but it's not the complete set of values. And so if you have a switch case where you're looking for Washington State, Pennsylvania, you should have a default case in there that would be for anything else. And then the client is coded up robustly for that and can handle it properly. So then adding new values is not a breaking change to the client. So extensible enums, the big feature here is that they're really just a thin layer on top of a string, and it allows new values to be added over time. But old values still should not be removed. Another thing that's typically used is to return back discriminated or polymorphic types from a service back to a client. This is a little complicated, so try to stick with me. Let's say that the service returns shapes back to the client. And right now, it has a definition of a rectangle shape, and it also has a definition of a circle shape. But in the future, maybe more shapes will be added, like triangle or polygon. So what I show here is what the JSON payload would look like from a service back to a client for a rectangle shape. It would have a field in here called kind, and then it's being set to rectangle. Everything that's in yellow is specific to this kind of shape that it is. So rectangle is the kind, and then a rectangle has an X, a Y, a width, and a height properties. Those are specific for rectangle. If you look next to it at the circle shape, if the service wants to return a circle back to the client, it would set the kind equal to circle, and then a circle has things that are specific to it, like an X, a Y, and a radius. It happens to be that rectangle and circle both have X and Y, but that's just coincidence. Now, shapes also have some things that are in common to all shapes, like fill color and line color. And maybe there's a subscription. I'm just making up some things to give some examples here. And the subscription has, let's say, an expiration on it that would be common for all subscriptions. But you might have different kinds of subscriptions to the circle. Maybe there's a free kind of subscription, like I show here for the rectangle, or maybe there's a paid kind of subscription for the circles I show on the right here, and then a paid subscription maybe has an invoice number associated with it. So what I'm showing here is the service can return a shape and the different things that are specific to it, and then within that there could be a nested property like subscription, and that can also be polymorphic as well. and have different fields that are specific to it. So this is the way the service would return these values. Now let's look at how we would model those in an SDK for a given programming language. Now on the far right here, this is what client library pseudo-types look like. I call them pseudo-types because I don't want to pick a specific programming language. Right? I want to get the concepts across because this might be mapped to many, many, many different programming languages. So in a programming language, we typically have a client class that represents the service we're talking to, and the client class has methods on it to perform operations on the service, and then each of those methods returns a response object back, and that's what we're talking about, is what it gets returned back. So we would model this kind of polymorphic type behavior in a client library by defining a data type, let's say a class or a structure, called shape. It's effectively kind of a base class, although not all languages have inheritance with base class and hierarchies. So in some languages, this might be an interface instead of a base class. Then there would be a string field on here called kind. There would be some data type for the raw JSON. This might be a string as well. So the raw JSON that came across the wire would be accessible using this raw JSON field over here. The reason why this is important is because let's say that in version 2 of the service, they did add a triangle, but a version 1 client requests the shape from the server and the server returns the triangle. Well, the v1 client only knew about rectangles and circles. It doesn't know about triangles. So the v1 client could look at the kind and say, I don't know what this is. It's not a circle or rectangle, so I don't know. Then it could look at the raw JSON, parse the raw JSON manually, and then with a v1 client, you could actually support triangle if you wanted to. Right? It's kind of an escape hatch. This raw JSON field is an escape hatch that's added here for versioning purposes, where a newer version sends back something unknown to the old version, and the old version customer don't want to upgrade their client library yet, but maybe would still like to write code to deal with this new thing that's coming back. They just have to parse the JSON manually rather than have it deserialized. Any of the properties that are common, like fill color and line color, those would still also be fields within this type. And then we would have subscription. I'll talk more about that in a moment. Then, depending on your language, you would have rectangle derived from shape, or it would implement the shape interface, and you would have the field specific to a rectangle. Similarly, for circle, it would be derived or implement the shape type, and then it would have the field specific for that. Sometime in the future, in version 2, there might be a triangle class, and that would also be derived from shape or implement the interface, and it would have whatever fields it needs in order to describe a triangle. For the subscription type, we would have another class or possibly an interface, depending on the language. It would also have a kind field in it, indicating what kind of subscription this is. The raw JSON field is there again as an escape hatch in case some new subscription type shows up in the future. And then they all had in common an expiration date, so I put that here as kind of a date time. And then lastly, you would see the derived types, if you will, or the types that implement the interface, free subscription and paid subscription, and they would have whatever fields are specific to those in there. And then if some new subscription showed up in the future, some new version of the client library would get the new class implemented down below. So the last thing I want to say that's on the bottom left of the slide is that these polymorphic types are hard to work with. In client libraries in particular, they are very hard to work with. And so when you are designing a service, we would really recommend you try to avoid this. But if you just can't avoid it, then this would be the pattern to follow because it is a version resilient pattern as best as possible. The reason why this has a bad developer experience is because your API in strongly typed languages is going to return the base type or interface. Then the customer has to write code to look at the kind field, and then they have to cast or convert to one of the derived types, which is a dynamic cast that happens at runtime, so it's not efficient, and also it can be wrong, so it can introduce potential errors that happen at runtime. It can't be statically checked at compile time. So it's not the best developer experience to be offering this. You should avoid it when possible. So it has the versioning issues I talked about. The derived class discovery in the editor is problematic. Like, how does the customer, when they're writing their code, know what types they can legally cast to? Some editors will show you that code completion, some will not show you that code completion. And then there's the runtime cast that I mentioned before.